Hello and welcome to another challenge, day 18. We're still in the cloud section playing with containers. Now, note if you are using the Try Hack Me free plan, the attack box does not have internet access and cannot reach AWS. You will need to install curl and the AWS command line on your own machine in order to complete this challenge. And here's a link to do that. As you can see, I have the attack box, so I will not need that. So the premise. Grinch Enterprises has been gloating about their attack on an underground forum. We know they were specifically targeting organizations in a campaign they've themed Advent of Cyber. What a frustrating coincidence. Tracing the user back over time, we also encountered a reference to using AWS Elastic Container Registry or ECR to store container images they use as infrastructure in their attacks. Let's see if we can find out more about the attack tooling Grinch Enterprises is using. So, in this challenge, we are using commands from the Docker tool and just a little bit about containers. It's a virtualization mechanism similar to virtual machines that are based on the Open Container Initiative distribution specification. But just a quick note, when people talk about Docker or containers, most times they're talking about multiple container technologies that work together. So when we say Docker, we usually mean the API or a local communication interface configured on a Linux machine with standard commands used to communicate with a Docker daemon. The Docker daemon, a process that runs on our machine to interact with container components such as images, data volumes, and other container artifacts. And then the Docker container image format, usually ultimately a tar file. And then for version 1, the Docker image format was not strictly compliant with the OCI image specification. And here's a link for that here. For our purposes, this won't change how we interact with container images in this exercise, but it does slightly change the format and content of a container image. So now that we have the basic terminology, let's get into it. So as the challenge says, we're going to talk a little bit about ECR or Elastic Container Registry, which is an online registry for public and private container images. And we'll learn how to retrieve a container image from an online registry and inspect the elements of that container image to identify potential security issues. So now, in a cloud native computing environment, containers are a first choice solution for deploying infrastructure. They're similar to virtual machines. The containers serve as the compute fabric for many running applications and hosted processes in the cloud. So I have my attack box open. So I want to open a terminal and I'm going to say Docker images. Okay, so let me make this bigger. And I have the 4 listed here: Sci-Fi, Ruscan, Empire, and CyberChef. And Docker containers are stored as repositories, which are referenced to file mappings in the Docker daemon, which knows how to reach them in a container and tar files. And as you can see, each image has an image tag, and images can be referenced either by their tag or their ID. So for example, you can reference them by Rumex Sci-Fi latest or this ID. Now, we have traced the Grinch Enterprises attack infrastructure back to an ECR that is publicly accessible. And let's pull it down. So we're going to say Docker pull public.ecr AWS H0W1J9U3 Grinch AOC latest. And as you can see, it's downloading and extracting. Okay, so it has downloaded. Now we can run the container by docker run it public.cr ecr aws h0w1j9u3 grinch aoc latest. Now, so we're in a shell, so let's say ls.la, which is going to list everything. And we just see the standard of the bash things. So nothing spectacular. So now it's saying a good place to check next is environment variables. So in Linux, and especially for containers, an environment variable may be used to store secrets. And remember, in previous exercises, especially with the misconfigurations, we saw it with the last challenge, with the cloud, with database secrets and things of that nature. Those things should be tight, right? They should be stored, or other sensitive information used to configure the container at the time. So we're going to print environment to get the environment configurations. And what do we have here? We have an API key that is public. And Grinch Enterprises didn't mean to leave that behind. So now, a container image is composed of a number of layers. Perhaps this is sensitive information in the underlying container layer that Grinch Enterprises didn't clean up as part of their build process. One key reason that developers and attackers might package their application or attack tools in a container is that a container allows a developer to freeze an application and its dependencies into an image as part of the build process. So this is part of the software development lifecycle, where applications and their dependencies are packaged together and tested prior to distribution and use. So once the image is built, running the container image will always result in the same configuration state as specified at build time. So Docker images are built from a source file known as Docker file. Docker files are a list of new line separated instructions that instruct the Docker daemon how to generate a container image. So then there's a Docker file reference at this link. And then you can see an example of a Docker file. So this is an example of a Docker file. In the case of Grinch Enterprises, we don't have the original Docker file, but with the container image, we have something just as good. So we're going to create a new directory, and we're going to get the downloaded image of the tar file. So let us exit. And we're going to make a directory. We're going to change it to that directory. And we're going to say docker save. Did I type this wrong? H-O-W. You gotta make sure you type it correctly, otherwise it's not gonna find it. Okay, once we have saved the image, we can further inspect it by doing tar xf aoc.tar. And we're going to extract it. And if it's saying if we would have used the V for verbose, it would have showed us all the files we would have extracted. So we're using the attack box so we can skip this, the JQ, because it's already there. So ls, okay. And it says this configure um, the first piece of the information in the file is config, which represents the underlying configurations and commands used to build the container image, and that's at this JSON. The configuration file is also located in the root of the unpacked container image directory and can be inspected in the same manifest. So let us, I'm going to say cat F8, and then you can type the first two letters and tab for autocomplete, and we're going to use the JQ to make it pretty, and then to make it look pretty like this. The first section of the manifest configuration file walks through the final image configuration as intended to run on a container host system. However, this next section is of particular interest to an attacker. Here's how the container image was built. You can see each section broken up by curly braces, and some of the sections have an extra line indicating empty layer equal true. Each of these sections are describing a particular command run by the Docker daemon at the time that the image was built, and if the empty layer equals true, configuration is now listed as part of the section definition, then the container layer is retained in the overall container image as one of the layers listed in the manifest.json file. Of particular interest, we notice the container contains a tool called enval console that is pulled from GitHub. Reviewing the GitHub repository for this, the about description states environment console is a tool that allows a user to launch a sub-process with environment variables using data from HashiCorp console and Vault. Noting that this source code was cloned into a root directory, perhaps there is something sensitive related to this repository that a regular container user isn't intended to see at Grinch Enterprises. Let's dig through the image layers and see if we can find out what is sensitive about it. We can more closely inspect the layers by switching to the subdirectories representing the layers in the unpacked container root directory. As we switch between these layers, we notice one layer of special interest. So here they're talking about this root here because it's in the root directory. So now if we go to the .44, and then we're going to go tar xvf, and Linux is case sensitive, so you need to make sure everything is lowercase. How it looks on the screen is how you type it. Okay, and then we're going to say cat root. And now we're looking at the configuration of this. And so it says this layer contains a configuration file. As we look at this file in the container image layer, it is clear that sensitive configurations are maintained in this file. Okay, there's our answer. Let's use Linux command tool grep and see if we can return a secret or a token. And there it is on line 4 when grepping with a string token. I wonder if the Grinch Enterprise developers know that the container image cached all of the container layers. Either way, now we can turn the tables on Grinch Enterprises and access their vault clusters with all its secrets. So let us and here's the token right here. So I'm going to work backwards. Here's the token. What is the name? Okay, what command will list images stored in your local container registry? Docker images. What command will allow you to save a Docker image as a tar archive? Docker save. What is the name of the file, including file extensions for the configuration, repository tags, and layer hash values stored in a container image? Manifest.json. Okay, so this was a very good challenge. Again, I really haven't played with containers. Cloud is, really not my thing. So this is really a good way to get my feet wet in it. So I hope you have learned a lot in this challenge. I have, and we have turned the tables on that Grinch. We have their token. We have their secrets. We found their token. We found their API. So now we can get into their systems and view their sensitive information. So this exercise, this challenge is good because it shows even when you build your containers, you need to make sure things that you want to keep private or secret, you need to make sure that they're stored. Otherwise, if they're left in the open and you build a container, they will be packaged or contained in the open, which means any and everybody can view it. So I can't wait to see you in the next lecture. Not lecture. Sorry, I'm a teacher as well. In the next challenge. Have a good day. Bye.